So I'm going to call this section other camera details. The way that cameras focus is really important to be aware of. They rely on contrast between pixels in order for the camera to register and focus properly. So what happens is if you're photographing at night or in other low light conditions, if everything is light to give you detail of edges, right? So if you are photographing over in a low light condition, what I tend to do is to either bring a flashlight that can shine into a scene, focus, turn off the flashlight, turn the camera to manual focus, and take a picture. Or I even just take my focus on that, pull the cell phone out, and then flip to manual focus and take a picture. But there's also a depth of field scale and a focal scale on some lenses. Usually older film camera lenses would have this, and now it's be able to essentially estimate where the focal point is. So like in this illustration, it's somewhere right around 9 or 10 feet. But you're able to estimate your focal distance along with, or your depth of field range along with this. So if you have, for example, a 4 aperture to 11 feet versus a 16 aperture, you can see the scale is much wider, and it goes from maybe 6 feet to 25 feet, we'll call it. So that can be very helpful talking about related focusing concerns and issues. And what people use distance scale as well as the depth of field scale in order to approximate when they're taking pictures of people and they don't want to hold the camera up to their face. So again, a little creepy, but street photography, if you don't want to capture your subject aware of you making a funny scowl or something like that, this would work. We haven't talked yet about white balance or color temperature. So a camera, this kind of relates back to the very first PowerPoint, might have register snow as blue or red, orange, if you remember right, depending on what the lighting conditions were. The camera was probably here at night. Your light is not daily balanced, and the lights are coming in with like sodium vapor or fluorescent or something else, and they cause these different color casts. You don't see it with your eyes because your brain automatically corrects, but the camera sees the color change. So this is our scale, and the idea is that metals that burn at a higher heat put off a more blue temperature, a cooler temperature, and those that burn with less heat have a warmer orangish or reddish feel to them. Change our white balance. So I'll give a preview of the menus of this in a video, actually changing it in the camera, but these are an example of different types of white balances. And so you can go through and just kind of go with whatever you think looks best in the camera. Keep in mind that when we get into software, we can actually color to be more neutral gray. And this is a scan out of a book, so again, it's not necessarily, there's no like perfect color balance in it. But I always like to ask students, well, do you think it is a blue like awning above the door? And is it white? Is it a cream paint on the pillars and it's a more neutral color on the awning or window or whatever that is? And it's kind of subjective. Everything is, you can probably estimate that maybe the brick is not actually completely neutral gray. So usually it's correct because the pillars look like they're the most neutral in color, but it kind of gives, it depends on context, I guess. So we'll set whatever we think is the best color balance in the camera, and then we'll perfect it in post-production. And one way to mathematically the right color balance, if we don't have something to base our color balance off of, so it's really hard to do with like a portrait typically because your skin tones can be a variety of red, orange, yellow-ish color depending on. So what a professional would do is have a color checker, which has a series of colors, different color patterns in it that you can actually use a computer program to create a calibration for your camera for. And then use a gray card, which is what's in the bottom left photo here, specifically made out of a material that stays most neutral in color in different lighting conditions. But what you could do, which is kind of what is happening in the top photo here, top center, is if you hold up just a white piece of paper, your camera, if you do custom white balance, which I'll try to show you, to actually white balance to whatever the brightest white in your scene is. So a white piece of paper tends to work pretty well for this, and it will make whatever is the brightest thing the kind of like the color balance will balance to make that neutral, I guess is what I'm trying to say. To be gray or to be white can be very helpful, and you could just take a picture of it and use that to set the color setting and apply it to the photos you're actually going to use, and just throw out the one with the picture of the piece of paper or gray card. All right, a couple other little things. A 10-second timer. This is traditionally for self-portraits in the time pre-selfie stick and selfies in general. Then there is a 2-second camera timer on most cameras these days. Some cameras actually have an intervalometer built into it, and most as an external device that plugs into it. And an intervalometer takes pictures at set intervals. So it's great for time-lapse photography, for example. If you want to take one picture every 30 seconds for the course of, I don't know, 5 hours or something like that, and see something changing. Most cameras these days allow you to do a tether capture. And this is usually through a USB cable of some sort, maybe even through HDMI these days. And well, the HDMI will output all of the view of the camera. So like if you're on a live view, see all the menus inside the camera, which is something I like to do if we're physically together in a classroom. However, tether capture allows you to actually connect to the Adobe software, and you can take pictures essentially through USB cable and activate the pictures straight into the computer when you're capturing it. So this is great in a studio lighting class, particularly for doing still lifes or portraits, and we want to be able to see them right away on a big screen. You don't need any of these, but keep in mind the 2-second and the 10-second timer are pretty standard on all cameras. The slow shutter speed to handhold a camera should be equal to or faster than your focal length. So if you have a wide angle, 28 millimeters, you can use a 30th of a second because you have less camera shake because you have a really wide angle view. But if you're zoomed really far in and using a 150 millimeter lens, for example, so that's that's 1, 2, 3, 4 stops difference between each of these. So again, pretty much in any situation, if you are slower than a 30th of a second shutter speed, you have to have a tripod. Any of these sort of matching numbers or fast time to handle. And if you have a crop sensor, you actually need to probably step up one shutter speed higher than most of these numbers, because you actually you have a 1.6 crop factor. It's essentially 2/3 the shutter speed that it should be. So when you're doing most things on a 17 to 55 millimeter lens on a crop sensor camera, you're probably fine at a 30th of a second. For the wide angle, you're probably fine at about a 60th of a second if you're in the middle of the range. And if you're at the, all right, last little topic here. When we're talking about film, or sorry, not film, camera noise, so caused by the ISO being really high, there are 2 different types of noise that you can have. Luminance noise is just looks like film grain essentially, and it's traditionally more acceptable. It is not going to draw the eye because it's fairly luminance kind of means brightness, so it is not colorful. Whereas chrominance noise, where the amplification in the pixels, you end up with these colors that just are not realistic. So this cat has these spots that are just like really vibrant when they shouldn't be. And this is usually something that happens in low light situations when you have more than one color sort, like color of light source, I should say, light on, and you've got an LED light, and maybe there's some little bit of light coming in from a window somewhere or street light coming in. You end up with like a bunch of different colors. So when you're not color balanced perfectly, colors just get really thrown out of proportion. So that is something that is less able to be fixed in software. All right, and that wraps us up.